This demonstration is the handheld Tesla coil. First, a disclaimer, safety first. You do not want to be operating a Tesla coil without getting hands-on training unless you're an expert in a Tesla coil. So this is just to give you a brief introduction to this, and I will give you one-on-one training if this is the demo that you're supposed to demonstrate. The first thing I'll show you is the operation of this device and how not to break it. This is the power button. It turns it on and off. This is essentially like the volume knob. So you want to be careful with this thing. We don't want to break it. So when you turn this on, you can hear there's almost no sparks. So now I'm going to adjust this knob until I hear a lot of sparks. So you can see there's a large range. Notice that I did not crank on this knob until it breaks. So please be gentle with this device. It's expensive. Now, when you're using a Tesla coil, first point it away from yourself and press the on-off button briefly and make sure it's not at high voltage. In this case, it's too high, so I'm going to turn it down to the smallest possible level where I'm still getting some sparks. And that looks pretty good. So one of the things we like to do with this is demonstrate you can exceed the breakdown voltage of air. Now, I've written that number down. It's 30,000 volts per centimeter. Now, there's a lot of factors that can affect that number, so that's not necessary. This is a good starting spot. So just remember that number, 30,000 volts per centimeter. So what that means, if my finger is 1 centimeter above the light bulb, I need a voltage or a potential difference of 30,000 volts between the light bulb and my finger to cause those sparks to conduct. Or said another way, 3 million volts if I'm a full meter away, say my arm's length, right? So if I wanted a spark to jump from the light bulb to my face, there'd have to be 3 million volts. Now this Tesla coil produces a very large voltage, but not that large. But we can see it does produce these 30,000 level sparks by putting my finger over this. Now this definitely hurts a little bit. So you don't want to try this unless you feel comfortable. So what you might do is turn down the sparks to the bare minimum and then try it. And you'll notice you can feel it. And notice I'm not touching the light bulb. The sparks are actually jumping all the way to my finger through the air. Now to cut the pain of this a little bit, you can use a coin, and that takes the edge off so that you don't get hurt. So that's kind of nice. And what's happening here is a circuit is being connected. So, right, this electricity must be flowing through me to the ground somehow. And there's something you can learn about the skin effect. A lot of people mistakenly think that when a lightning bolt strikes a car, you're safe because the tires insulate you from the road. That's not true. The electricity from the lightning bolt is conducted over the surface of the car, and then it jumps to the ground. So it's not the insulation of the tires. Just know that. Someone might ask you about that. That's something you could discuss with people if you wanted to go further into this. How does the Tesla coil work? It's different than a Van de Graaff. People might ask you about a Van de Graaff generator. That's the one where they put their hands on the dome when their hair stands out, or you can watch that video separately. In that case, you're dealing with static electricity or static charge buildup. So when you scuff your feet on the carpet and touch, you build up a spark and you get a spark that way. That's a static charge. This is high frequency current. And so that's why it operates a little bit differently. There's a total different set of safety standards, but it actually helps us out and it's a little bit safer. Inside of here there's a transformer, and when you jack up the voltage to these very large levels of 30,000 volts per centimeter, when you jack up the voltage to that giant level, you're actually decreasing the current, and the amount of energy stays the same. Power is IV. If you're into that, you can discuss that. But that's, most kids just want to touch the sparks and see it. You'll also smell a little ozone coming off, the O3. So that's kind of interesting. So this is good to do out of doors if possible, or have it in a ventilated area. So why don't we take a look at the close-up and see how it looks.